we know what is transportation model. We know how to compute the lowest cost by transportation model. Now, assignment model, let's understand what it is. Let's say we have n number of workers 1 2 3 up to n, and we have n number of jobs 1 2 3 to n. If it is not equal to n but m, what we can do, if you have a you must understand transportation model before understanding this. So if this is unbalanced, we can add fictitious workers or fictitious jobs to balance this. That is, make this, if this is n, this also n, whichever is less will add. If this is less, we'll add some workers, and if it is less, this one is less, we'll add some jobs, so that this is n to n. Now, if we have n number of workers and we have n number of jobs, and this worker can do all these n jobs, this second worker can also do all the jobs, third worker can also do all the jobs. Clear? First thing is, we have n number of workers and n number of jobs. Now, every worker can do all these jobs. The only thing is, the cost of doing that job is different. Maybe when worker 1 will take, let's say, rupees 10 to do this job, first job, he will take rupees 50 to do the second job, and similarly he'll charge differently for other jobs. He may not be doing any work. For that, the cost will be 0. Now, let's say 2 will take rupees 12 to do first job, 2 will take rupees 15 to do the second job, and so on. Our problem is which worker to be assigned which job, so that the total assignment cost is minimum. Let's make the table. Let's make it for 3 cross 3. That is, there are 3 workers and we have 3 jobs. Let's say this is worker 1, this is 2, this is 3, and this is job 1, job 2, job 3. These are jobs and these are workers. So what we do? Let's say the cost, he is charging 10 for first work, 12 for second work, and 15 for third work. That is, worker 1 charges rupees 10 to do the first job, he charges rupees 12 to do the second job, and he charges 15 to do the third job. Similarly, let's assign some values: 7, 9, 8, 15, 2, 8. So this is the charges, and that is the charges by the workers to do certain job. What is demand and supply? See, the demand is 1 only. Only 1 can do the job. You don't need 2 workers. 1 will do the job. So demand is 1. Similarly, supply. What can 1 worker supply? He can supply 1 worker only. So this is a unique case of transportation problem where demand and supply, all variables are 1. 1, 1, 1. A worker is 1 only. He can supply 1 worker only. He can also supply only 1 worker, and he can also supply 1 worker. Similarly, to finish that job, only 1 worker is required. So this is the transportation model. What we can do, we can solve it by transportation model. We know how to solve problem by transportation model. So perfectly we can use this method to be solved by transportation model. How that can be done? You know it very well. We'll start with, let's say, the least cost method. By using that method, we'll get the basic feasible solution. Then we'll test for optimality. If it is not optimal, we'll decide the entering variable, then the leaving variable, and the process is repeated till we get the least cost. So this can be solved by transportation method also. That is to say, but we have better methods also. What I am trying to say is that assignment model is basically a transportation model, or it is a special kind of transportation model where all variables of demand and supply are equal to 1. That is, every demand and every supply is equal to 1. So it is a special case of transportation model. We can solve it by transportation model also, but we have easier and more efficient method than the transport model for solving the assignment model. The model that we'll be using is, the method that we'll be learning now is called Hungarian method. It is a method of solving the assignment problem. Okay, so again I am saying this can be solved by transportation model also, but an easier and more efficient method is Hungarian method when we have to solve assignment model. So we'll take an example and then we'll understand how Hungarian method is what are the steps involved in Hungarian method, and then we'll see what is the least assignment cost. See, this is example. These are workers 1, 2, 3. Worker 1, worker 2, worker 3. These are jobs. Job 1, job 2, job 3. Worker 1 charges rupees 15 for work 1. He charges rupees 10 for work 2. He charges rupees 9 for work 3. Similarly, worker 2 charges rupees 15 for job 2. So this is clear. We have to find assignment. Which worker should be assigned with which job, so that our overall assignment cost is minimum. What we do? See, step 1. We find PIs. What are PIs? PIs are the lowest cost of a row. Lowest cost of a row. So PI you can write this side or this side. We don't have space that side, so I'm writing to this side. PI, that is P1. P1 here is, which is the lowest cost? 9. P2, which is the lowest? Again 9. Here 10, 12, 8. So P3 is 8. Then what you have to do is subtract all the entries of a row by PI. That is, we have P1 as 9. So what we'll do? 15 minus 9, then 10 minus 9, and then 9 minus 9. This we have to do. Similarly here, 10 minus 8, 12 minus 8, and we'll form a matrix. What you should do is that you should keep writing with me, because I'll be rubbing, so you won't get it. You should write, find PIs. What are PIs? The lowest cost of a row is PI, and subtract all the entries of a row by the corresponding PI. This you should write as step 1. So if you do this, the matrix that you will get is like this. So the matrix that we will get is like this. So 15 minus 9 is 15 minus 9, 6, 10 minus 9, 1, 9 minus 9, 0, 9 minus 9, 0, 15 minus 9, 6, 10 minus 9, 1, 10 minus 8, 2, 12 minus 8, 4, 8 minus 8, 0. So this is our new matrix. This is for the workers 1, 2, 3 and job 1, 2, 3. Okay. This is step 1. Now, what is the step 2? Step 2 is find QJs. QJs for each column. P's were for each row. Q for each column, and the concept is same. What is QJ? The lowest of that column, the lowest cost of that column. So from here, Q1 will be, which is lowest? 602. Out of these 3 rates, which is lowest? 0. Then this one, Q2, 164, so it is 1. Then Q3, it is 0. We have 2 zeros. Okay. And the next step will be subtract all the entries by Q. As we did for for rows, we'll do for this. That is, subtract, after finding the Qs, subtract all the entries of that row by the corresponding Q. Okay. So let me draw it here. So our new matrix will be like this: 1, 2, 3. This is worker 1, 2, 3. This is job 1, 2, 3. So we have to minus 0 from this. So this will be same 602 minus 1. So it will be 0, 5, 3. Then minus 0. So 0, 1, 0. So this is our new matrix. Now what you have to do? See if assignment is possible. See if assignment is feasible. Can we assign one job to one worker from this? So which one we assign? The question is, I said, see whether it is feasible or not. The test for feasibility is all the entries, all the variables which are equal to 0. So we have 0 here, we have 0 here, we have 0 here, 0 here. So those variables are taken as the basic variables. So if from this we are able to assign one worker to one job, that is 1, 0 can correspond to 1, then we know this is a basic feasible solution. See, for worker 1 we can say this one, worker 2 we can say this one, and worker 3 we say third job. That is, we have assigned worker 1 to job 2, worker 2 to job 1, and worker 3 to job 3. This is possible. So this is feasible. That is, we have reached our optimum solution. And if you want to know what is the assignment cost, you will just have to see what was the cost. That is worker 1 for job 2, worker 2 for job 1, and worker 3 for job 3. You can see back, I am also looking what was the rate. 1, 2, 10, 9, 8. So this was 10, this was 9, this was 8. So this is rupees 10 plus 9 plus 8. That is rupees 27. So the minimum cost of assignment is 27. So it is as simple as this. But we have found our feasible solution, our optimum solution very simply here. But there will be cases when you won't be able to find solution here. For example, if this was here, if this was not 0, then third worker was also available with job 3, and first worker was also available with job 3, and no one was available for job 2. If this was not 0, it was 1, 2, 3, anything. So that case can also appear. Okay. So let's see an example where we have such a conflicting situation. Then how to solve that. Okay. So we'll start with PEQ, and then when we'll have conflicting situation, that is we won't be able to assign, then we'll understand what needs to be done. Okay. Let's see that example. Now let's see this example. We have 4 workers and 4 jobs, and the charges are different. See, the first worker takes rupees 1 for job 1. He takes rupees 4 for job 2, 6 for 3, and 3 for 4. Similarly, worker 2 takes 9 for 1, 7 for 2, and so on. Let's solve it. So the very first thing is we find P's, which is P here, it will be 1. P1 is 1. See, this is the lowest value. P2 is 9, 7, 10, 9. So it is 7. 4, 5, 11, 7. So P3 is 4. P4 is 8, 7, 8, 5. So it is 5. First step done. What we do? We subtract all the variables of that row by that P. So I'm doing this first step. See, it will be 1 minus 1. So this is 0. This is 4 minus 1. So this is 3. 6 minus 1. So it is 5. 3 minus 1. So it is 2. Then here 7. So this will be 2. This will be 0. 2 and 0. 2, 0. This will be 3. This will be 2. 3 and 2. Then this is 4. So this is 0. This is 1. 0, 1. 11 minus 4 will be 7. This will be 7. This will be 3. 7 and 3. Minus 5. So this will be 3, 2. 3, 2, 3. 3, 2, 3, 0. 3, 2, 3, 0. 3, 2, 3, 0. Okay. So from P's we have found this new matrix. Now what we do? We take Q. Q, this is Q1. The lowest one is 0. Q2, again 0. Q3, which is the lowest one, it is 3. Q4, again 0. So now what we'll do? We'll subtract all the variables from this for every column. This is 0, so this is unaffected. Again this is 0, this is unaffected, this is 0, so unaffected. Only this one is 3. So here we'll subtract all by 3. So this is 0, this is 0. 3 minus 3, 0, this is 0. This is 4, this is 2. 4, 2. Now let's see if this solution is optimum. See, first worker 0. So we can assign first worker to first. That is worker 1 we can assign to job 1. Then worker 2. See, worker 2 has 2 possibilities, job 2 and job 3. Again, worker 3, he can only opt for job 1. And worker 4, he can opt for J3 and J4, third and fourth. So we can say that if J2 and J3 is there, we can leave this with W2, that is second worker, and we can then we can put J3 with this worker. But what about J4? This work, no worker will be left for this assignment. Similarly, W1 and W3 both want J1, so we'll be left with we have one job and two workers. So this is not the optimal solution. So up till now we had done in our last example and we had found that it was the optimal solution. What if this is not the optimal solution? Then we go to our next step. See it properly. What we do? We select the rows and columns, or to say the minimum number of rows and columns which should cover all the zeros. It cannot be diagonal, it can be horizontal or vertical only. So we select rows and columns, minimum number of rows and columns, so that all zeros are covered. We can cross it or we can shade it. So if you have highlighter on pen and paper, you can highlight the that particular row. Here what I'll do, I'll cross it. So this, so we have crossed two rows and one column. Crossing two rows and one column, we are able to cover all the zeros. Okay, clear? This is the first step. Up to that, we have written the steps. Now, let's say this is step 3. So what we do? Cross cross the minimum number of rows and columns so that all zeros are covered. Okay, this is the first step. Now second step, we have uncovered cells. Let this be 1. Then select the lowest cost from the uncovered cells. We have uncovered cells. These are uncovered cells. This. Which is the lowest cost? This is 3, 2, 2, 1, 4, 3. So the lowest cost is this one, 1. So this is 1. Now what do you have to do? The next step, we have selected, select the lowest cost. What will be the next step? The third step. Third step is subtract all uncovered cells by this value, that is 1. So we have uncovered cells, these 6. So 1 minus 1, it will be 0. This will be 4 minus 1, 3, and this will be 2. So 3 and 2. This will be 2, 1, 1. 2, 1, 1. Now, fourth. The intersection points, add this value, that is which value? This 1, that is the lowest one, to the row column intersection variables. Which are row column intersection variables? See, this one, this is row and column intersection, and this one. So what we'll do, we'll add this value 1 to these two. So 2 becomes 3 and 3 becomes 4. Okay. Now let's see, is the solution feasible? See, this is 0. So worker 1 is assigned job 1. We have two possibilities here. See, worker 2 and worker 3. Worker 2 can be assigned this and this job, and worker 3 can be assigned this and this. So if we assign this job to this worker, then we'll be left with this only for this. Then it will conflict with this. So what we do? We will assign this work with this worker. So W2 worker second will be assigned job 3. Then worker 3 will be assigned job 2. Okay. So now job 3 is already assigned. So what we do? We have job 4 for the fourth worker. So now you see this is the conflict has been resolved, and so we are able to get the assignment. If you talk of cost, Let's see, these are the, see, worker 1, job 1. Actually, finally what we did, our assignment is this, W2J3, then W3J2 and W4J4. What were the cost, what were the charges? You can see in the start, I'm just looking at it. So this was 110.55. So the cost will be 1 plus 10 plus 5 plus 5 rupees. So this is rupees 21. So rupees 21 will be the cost of assignment. Okay. So even after this, if you find this is not assignable, then what you will have to do? You will again take row and column, shade it, same process. You will repeat this process. Finally, you will get exact, completely exact assignments, and then you can see what is the cost. So this is the cost. This is the lowest cost of assignment. So I think assignment problem is clear to you. Try for yourself. Try some examples from book.